Hi. So today I want to go over some geometry concepts, in particular transformations. So what a transformation is you're basically taking a shape on a plane. So like we have this quadrilateral right here, and we are either going to change its orientation or change its orientation, or we're going to change its location, or even change its size, right? Because dilation is one of the transformations that we have. So today we're going to be looking at translations right here. So translation is when we change the location of the points, right? In other words, right, we're gonna slide all the points over however many units that the question tells us, right? That's all we're doing. We're not going to change the way it's we're not going to change the way it's oriented, and we're not going to change its shape. All we're doing is just sliding each point by what the question tells us. So let's look at the first one. So let me erase this on the side. So since we're sliding, number 1 says translation 3 to the right. So that means we have to slide over every point 3 spaces to the right. So let's look at this first point right here. So if we move it 3 to the right, it's going to be 1, 2, 3, and that's our new point. Next, we're going to do this this point over here. So 1, 2, 3. It's going to be right there. Let's do this point next. 1, 2, 3. Right over here. Oops. Right over there. And finally, this corner right here will be 1, 2, 3. And then once we connect all our dots, right here. It's not the neatest. We notice that again, it's the same shape, it's the same size. All it is just we just slid it over 3 spaces, and that's all translation is. So let's look at the second one. 2 right and 3 down. So once again, all we're gonna do is move each point 2 spaces to the right and 3 down. So let's look at this point. So it'll be 1, 2, move 2 to the right and 3 down. 1, 2, 3. Next, we'll look at this point. So it would be 1, 2, and then 3 down. 1, 2, 3. Awesome. Now let's look at this point right here. So 2 to the right, 1, 2, and 3 down. 1, 2, 3. And finally, our fourth point right here would be 2 right and 3 down. So 1, 2, and then 1, 2, 3. Oops. Okay, and so again, when we connect all our points, let me retry that. Right, my drawing looks a little bit sloppy, but it'll be the same shape. All the points are just slid over exactly what the question is. 2 right and 3 down. So that's all translation is. So I encourage you, if you have extra loose leaf or extra graphing paper preferably, to give this a try. So copy down question 3, this little triangle right here, and slide it over 5 spaces to the left and see what you get. So we'll keep working on this. We'll keep working on this example together. So this triangle, we move over 5 to the left. So we'll take this point. We'll move 1, 2, 3, 4, 5. Take this point. Move over 5. 1, 2, 3, 4, 5. And finally this point. So 1, 2, 3, 4, 5. We connect our points. And this is our answer. So when we translate 5 units to the left, this triangle 5 units to the left, this is the triangle we end up with. So let's look at something a little bit funky. So let's look at number 4. So 4 is a bit of a weird shape. It's not a quadrilateral, but it has 1, 2, 3, 4, 5, 6, 7, 8 points. So we got to move each of the 8 points 4 units to the left and 3 units down. So let's see. So 1, 2, 3, 4. 1, 2, oh, sorry, and 3 down. So 1, 2, 3 right here. So 1, 2, 3, 4. 1, 2, 3. Right there. Oops. Right there. 1, 2, 3, 4. Let's do this one. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. And then boom, boom. Okay. Yep. So as we see, we have this kind of like Z looking shape, and we have it 4 units left and 3 units down. So you kind of get an idea of what we're doing here, right? We're just sliding over all the points by exactly what the question tells us to. So I also encourage you to take a look at question 5 and question 6 and do it on your own. You can take a look at the previous 4 examples to see exactly how we translated. It'll be the same exact steps. So 5, take each point, move 4 spaces to the left, and then 5 down, and then connect all your dots to remake the shape. Next, I want to work on reflection. So kind of like what it sounds like think of a mirror, right? When you look into a mirror, you're looking at the same image, except it's reflected back at you. So in this case, when we have the first question, it says reflect over y equals 0. Well, what is y equals 0? Well, that's the y-axis. That's this straight line right here. So if this was a mirror, right? If this y line was a mirror, and this shape was looking at the mirror, what would the shape see? Well, it'd be flipped over. So how do we do this? Okay, so we're gonna take each point. So let me highlight the points we have. We have this point, and this point. Right? We have a triangle, 3 points. And when we want to reflect over the y-axis, we want to find how far away each dot is to the line. So we see this top point is 1, 2. 2 spaces away from this line. So on that same line, we're going to count 2 spaces. So 1, 2. And then we're going to write our new dot right here. Boom. Now we've reflected this point over the y-axis, right? Because it's on the other side of the y. Now let's do the other points. Let's look at this point. Now let's do the other points. Let's look at this point. This point is 1, 2 spaces from the y-axis, the thing we are reflecting over. So we're going to start at the y-axis and go 2 spaces. 1, 2. Great. Now we have our second point. Now finally our third point over here. So count how many spaces. 1, 2, 3, 4, 5. So this point is 5 units away from the y-axis. Now we're going to count 5 units away from the y-axis on the other side. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. All right, so now that we have all our points, let's go ahead and trace. And once again, my drawing will probably not be so neat. But more or less, we have our shape now. So we have our triangle. Our new triangle is the same thing as the first one, as the given triangle, except now it's reflected over this y-axis. So let's do another one, right? So let's look at our second one. Reflect over x equals 0. Well, we got to ask ourselves, what is x equals 0? Well, when x equals 0, that's a straight line going sideways. So it's just the x-axis. So we're asking what happens if we flip this shape over the x-axis, over this line right here. So same process, right? We're going to find out how far each point is from the x-axis, and then we're going to count that many spaces away from it on the other side. So let's look at this top point right here. So it is 1, 2, 3, 4 spaces away from the x-axis. So we'll count away 1, 2, 3, 4. That's our new point. Now let's do this bottom one over here. So it is 1, 2, 3, 4 spaces away from the x-axis. So we'll count 4 spaces away on the other side. 1, 2, 3, 4. Same thing over here. 1, 2, 3. So we're going to count 1, 2, 3. So notice how the points flip. So if this top point was above the x-axis, now it's below it. And if these 2 points were below the x-axis, now it's above it. So when we go to trace our lines, it's flipped. It's the same triangle, same shape, same angles, but it's just flipped over the x-axis. It's pretty much just upside down. Now let's look at another example. So this one is a little bit of a better example. So let's look at this triangle over here. So let me just highlight the points. Okay, so if we go 1, 2, well, first off, it says reflect over the x-axis. X equals 0 is the x-axis. So let's highlight the x-axis and count how many spaces away is this dot, this point from the x-axis. So it'd be 1, 2, 3, 4. So we go 1, 2, 3, 4. Right here, let me double check. 1, 2, 3, 4. 1, 2, 3, 4. This dot is right on the x-axis. So it's 0 spaces away from the x-axis. So it stays there because 0 away from 0 is also 0. All right. So let's count this point. So 1, 2, 3. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So we kind of we kind of have to fill it in because this example actually doesn't go that low. The graph doesn't go that low, but that's okay. So we'll connect our dots. So again, it's the same triangle, just flipped over the x-axis. It's just reflected over x equals 0. So let's try our last example. Let's try reflect this over y equals 0. So once again, y equals 0 is just this line. It is the y-axis. So let's highlight our points right here, and right here. Okay, let's start with this point over here on the right. So this is 1, 2, 3, 4, 5, 6 spaces away from the y equals 0. So we're going to count 6 spaces away on the same line. 1, 2, 3, 4, 5, 6. Now we count this one. 1, 2, 3, 4, 5. Now we go 5. 1, 2, 3, 4, 5. And this dot, since it's on the y-axis, it's going to stay there. It's just going to stay there. So we're going to connect our dots. Oops. And we have our triangle reflected over the y-axis. So reflection, the process of reflecting a shape over a line is just like looking at the points. So the process of reflecting over any line, whether it's x equals 0, y equals 0, or even if we get a line like x equals y or x equals 2 or y equals 2, would be to just count the spaces from the point all the way to the line you're reflecting. So in this case, in the example we just did, right, we took this example dot and we noticed that it was 6 spaces away from y equals 0. So we're going to go 6 spaces away in the other direction. And that's where our new dot will be. So I hope this helps in learning a little bit about transformations, especially with translations and reflections. Thank you.